Hi, my name is Harman Sandhu, and this is my Project 3 demo for takemeter. So for this project, I built a fine-tuned text classifier that evaluates discourse quality in NBA Reddit communities. And the goal was to determine whether a machine learning model could distinguish between three different types of NBA discussions, which are analysis, hot takes, and reactions. So I chose NBA Reddit communities because they contain a huge variety of discussion styles as some users will provide basketball analysis with evidence, statistics, and reasoning, while others show like stronger opinions with like very minimal support. And those are like commonly called hot takes. And users also simply react emotionally to games, trades, injuries, and player performances in general. And now let's begin by showing my GitHub repository. So at the top of the repository is my README file. Excuse me, at the bottom. And then this contains my final report, evaluation, and the results, along with the confusion matrix analysis and error analysis. And I also have a planning document. This planning document was created before I started implementation and contains my label definitions, edge cases, evaluation plan, success criteria, and AI tool plan. And now I have my data set. So, and this contained all of my labeled examples, which I had about 229 of them. And in my outputs folder back here, I have my JSON file right here. And that contains like a fusion matrix image and evaluation rate JSON file. So as I said before, the data set contained 229 comments that I got it from three different Reddit threads. And most of the data came from our Reddit. And I intentionally selected the comments that represented different styles of discussion so that the model would have examples of all three labels. So for my analysis comments, they provided evidence, reasoning statistics, and observations. And an example of analysis would be a comment explaining why a team's defensive rotations are effective or why a trade failed based on roster constructions. And then my next label was hot takes, which are just like bold opinions, extreme claims, or strong predictions that I express confidently, but without like substantial supporting evidence. And my third label was reaction, and those are just like emotional responses, celebrations, jokes, or memes, such as like wow, or like the ref stole this game, or this team is just like cooked. And after I collected the data, I manually reviewed and labeled every example. I did not rely on automatic labeling because I wanted the labels to remain consistent with the taxonomy that I designed. And now I'll discuss the model training process. So I used Distilbert with specifically the Distilbert-based uncased model from Hugging Face, which is a smaller, faster version of BERT that still performs well on text classification tasks. And this training was performed in Google Colab using a free T4 GPU. And for the data set, I was automatically split into training, validation, and testing sets. So I'll go back to my GitHub repository and go to my evaluation results here. After training, the model achieved an overall accuracy of 48.6%. And for the analysis class, the model achieved a precision of 50%, a recall of 94%, and an F1 score of 0.65. For the hot take class, the model achieved zero precision, zero recall, and zero F1 score. And for the reaction class, this model achieved a precision of 0.33, a recall of 0.12, and an F1 score of 0.18. And although the overall accuracy was below my target goal, the results still revealed interesting patterns about what the model learned. And now I'll show my confusion matrix. Okay. So the confusion matrix makes the model's behavior much easier to understand. The model correctly classified 16 out of 17 analysis examples. However, it classified 9 out of 10 hot takes as analysis. It also classified 7 out of 8 reactions as analysis, which tells us that the model developed a strong bias toward predicting analysis. And now I'll discuss my three incorrect predictions. So the first one was the Cavaliers have no chance of winning game 7. if Mitchell keeps playing this way. The true label was hot take, but the model predicted analysis. So the error occurred because the phrase if Mitchell keeps playing this way sounds like basketball reasoning. However, the statement ultimately makes a strong unsupported prediction, which fits the hot take category. And the second example is simply just wow. The true label is reaction, but the model predicted analysis. And this kind of demonstrates that the model struggled with extremely short comments since there is almost no information present. The model appears to default toward analysis. And the third example here, it was the Luca versus Wembanyama discussion highlights the tension between proven production and future upside. And the true label was analysis, but the model predicted reaction here. And this example is interesting because it shows a different failure mode, as it is an analytical comment, but because of conceptual reasoning, rather than statistics or direct evidence, the model appears to have learned to associate analysis with obvious basketball evidence, rather than just broad reasoning. And one of the major lessons I learned from this project is that label design is often harder than model training. And training the model only took a few minutes. Designing the labels, collecting examples, resolving edge cases, and ensuring consistency took much longer. So if I were to continue this project, I would collect significantly more hot take and reaction examples. I would also add more borderline examples that demonstrate the difference between evidence-based reasoning and unsupported opinions. And another improvement would be involving a second annotator to measure agreement rates and like determine whether some of the labels themselves are subjective. But overall, this project gave me hands-on experience with data set design, model fine-tuning, and just error analysis in general, even if my percentages were low. And that'll be it. Thank you for watching my takemeter demo.